Good evening, everyone. Institute of Town Planners India Kerala Regional Chapter is organizing yet another web talk on how to make Kerala resilient from disasters. To officially start the web talk, I invite Sri Denzel Fernandez, Deputy Town Planner of Local Self Government Department Planning and Executive Member of ITPA KRC, to deliver the welcome address. Over to Denzel.
Thank you, Rachi. Good evening, all. I hope it is audible to everyone. I hope a handsome number of participants has joined already. So I'm straight away going to my designated function. How to make Kerala resilient from disasters is one of the very prominent or one of the very sought after topics after the experience of recent disasters. And for that, we have the most appropriate panelist with us today. So Institute of Town Planners India, Kerala Regional Chapter, is very glad to welcome Sri Pradeep Kumar Sir, Secretary General, Institute of Town Planners India, New Delhi, to this session. He is the Additional Chief Town Planner, Urban Development and Housing Department of Government of Rajasthan. He is also an alumni of IIT Kharagpur, and he has been the Secretary General of Institute of ITPA India and have been an active member of ITPA India for quite some time. So welcome, sir. Welcome to this session. Next, I would like to welcome the moderator of the session, Dr. Ajit Kaliat, who needs no formal introduction actually. He has been with us as the Urban Chair Professor with the Kerala Institute of Local Administration. He is a PhD holder in Human Geography from the United Kingdom. After his PG Diploma in Urban Planning and Urban Planning from the SEPT University and MSc Applied Geography from University of Madras. He's a holder of multiple national and international certifications and fellowships, and a member of many state-level committees, policy-level committees of Government of Kerala, including the member of the state-level steering committee for urban reforms of Government of Kerala. His expertise includes urban resilience, cities and technology, democracy and planning, inclusion, child-friendly urban planning, etc. So we have the most appropriate person to moderate the session for the day. So welcome, sir. Welcome, Dr. Ajit Kaliat, to this web talk series. Next, we have the prominent speaker, Dr. Abhilash is with us. He's an associate professor of the Department of Atmospheric Sciences, Cochin University of Science and Technology. He is a PhD holder, and after his MSc in meteorology, both from QSAT, he has had his experience at Indian Institute of Tropical Meteorology as a scientist, along with multiple international exposures and experiences. He's a celebrated author of about 14 books and 78 journal publications, and about 70 conference presentations and publications. So his areas of expertise includes climate modeling, climate dynamics, prediction of Indian summer monsoon, clouds and convection dynamics, etc. So we have the most appropriate person with us as the speaker on this session on how to make Kerala resilient from disasters. So welcome, sir. Welcome, Dr. Abhilash, to this web talk series. I would like to render a warm welcome to Sri Akhil PR also, Treasurer, Institute of Town Planners India, Kerala Regional Chapter, and Assistant Town Planner, LSUD Planning, who will be rendering the vote of thanks for this function. And lastly, but not least, I would like to welcome all the participants to this web talk series. This has been a continuing practice for ITPA Regional Chapter since the pandemic days. So we are carrying on with this even after those, after the physical meetings are being enabled, so that more participants can join in the web talk series. So welcome each and everyone to this series, and I would like to welcome Sri Pradeep sir for his introduction. Thank you, sir.
Thank you, Denzel. At the outset, thanks to the office bearers of Kerala Regional Chapter for inviting me to introduce the theme for today's web talk. Dr. Ajit, we know him for a long time. Dr. Abhilash, who is the expert speaker for the day. On behalf of Institute of Town Planners India, I appreciate the efforts of Kerala Regional Chapter, particularly the ball rolled last year or last 2 years by Professor Jay Kumar. He started conducting webinars almost every month, and I'm happy that his successors, they are continuing with the same spirit. And it's really remarkable that Kerala chapter is doing lots of activities as far as the town planning profession is concerned. Today we are going to discuss how to make Kerala resilient from disaster. Disaster is not only limited to Kerala, but it can occur any place. Disaster can be caused on earth, on water, in the air, anywhere, because it is characterized by suddenness, unexpectedness. It leads to significant destructions, not only of the material, but human life also. That is the reason we have to think about that, how to make any place resilient from disaster. If we see the history, disasters keep occurring. Kerala being a coastal state, it is more vulnerable to the disasters from sea. And the reason for that is the climate change. Many factors which are influencing the change in the climate, and it leads to the rise in water level of sea, and subsequently, or rather consequently, it leads to many disasters. So these are the natural disasters. Here we are discussing only about the natural disasters, because man-made disasters are not the job of urban planners. It is to be looked after by great politicians, bureaucrats, and other people. We are more concerned about the natural disaster and how to reduce its impact if at all it happens. So, how to make Kerala resilient from disaster? It is important for us to know the causes of disaster. Then only we can arrive that how we can make the state resilient to disaster. I personally feel the root cause of natural disaster is climate change. Which activities are responsible for climate change? As estimated by UNFPA, that 55% of people live in cities, though in India, it is estimated that by 2050, more than 50% of Indian population would be living in cities, though the cities contribute hugely for the GDP of any nation, but there are certain hidden conditions which make cities as a contributor to climate change. For example, if we see the 75% of carbon emission as per the finding of UN Habitat, the urban greenhouse gas emissions through electric generations, transport, industries, and other urban activities, they are contributing more to the climate change than the countryside of the India. So we have to concentrate that how to reduce the carbon emissions in the cities, which may lead to the control of climate change. Worsening of climate change leading to extreme rains, droughts, rising of sea levels, heat stress. Therefore, the climate change also impacts socio-economic conditions of citizens. Thus, cities are massive contributors to climate change, and any proposition to make a resilient from disaster, we have to address the issues of climate change also. Since I come from the state of Rajasthan, we don't have disasters as you have in Kerala, but definitely we also have disasters. To cope with, historically, the cities in Rajasthan, they were built around the nature with features like water reservoirs, wind channels, because the Rajasthan is desert state and we have the problem of drinking water, extreme heat conditions. So all the development, all the planning of the ancient cities of the state, they were closer to the nature. But over a period of exploitation of natural resources impacting the climate, and I tell you that if you go to Jaisalmer, some of you must have visited, it's a Sonar Killa, a golden fort, and it's built according to the sun, and it was ensured that every drop of water is required to be conserved to avoid the disaster, the extreme heat conditions. And they're perfectly functioning till a very late, say up to 1950, they were functional. But over a period, the greed of the people, the human being, they encroached upon all these natural structures like ponds, water bodies, reservoirs, and even the man-made structures like step wells, which were constructed for the storage of water during the extreme hot climate. They have been encroached upon and destroyed to the extent of no use. So these are the phenomena, these are the structures we have to keep in mind when we take on the strategy of making any place as a resilient from disaster, whether it's Rajasthan or Kerala, doesn't matter. The issues may be different, but the problem is same. So with these words, once again, I'm very keen to listen to the experts, Dr. Ajit, who is moderating this session. I hope we'll get some input from you. And of course, Dr. Abhilash, I'm looking forward for this. Now I'm seeing Professor Jay Kumar also. Good evening, sir. I have appreciated your efforts for Kerala chapter. You started the ball rolling and your successor are successfully conducting these events. I'm very happy about it. Thank you very much.
Thank you, sir.
Thank you, Kapoor Sahab. It was a good overview and also helping us to understand the challenges in front of planning fraternity and also how the modern society need to be better prepared to address these challenges. So I think we have Dr. Abhilash, who has been doing research, a lot of empirical evidences, and particularly his work on Kochi and other coastal areas of Kerala. Many of us have been able to interact with him and get his inputs. Look forward to have a enriching discussion subsequently. Abhilash, hope you are able to hear us. Dr.
Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes.
Yeah. So over to you. Kindly take
Yes,
us to
thank
another
you.
exciting session.
Thank you, sir. Thank you, sir. At the outset, I should thank the organizers, especially ITP, Kerala chapter, for inviting, for giving an opportunity to interact with the planners, especially because we have been interacting with the town planners through some other lecture series coordinated by Professor Ajit at Kila. Yes, I will be talking on what are the recent disasters, how we can better prepare for these disasters in terms of early warning systems and what we can expect in the future, so that how we can make urban cities more resilient and more sustainable to the native people to live in urban cities, and also the whole population of the urban cities. So let me share my screen. Is this visible? It's in full screen.
Yes, you can make it full screen. Otherwise, it's visible.
Okay.
It has gone now.
Is it full screen now?
Yes.
Okay. Okay. Yeah. Today's topic is how to make Kerala resilient from disasters. So in this, I will be covering why Southeast Arabian Sea is becoming a hotspot for a lot of climate events, extreme events, and its potential impacts on disasters in Kerala, and a role of early warning systems to better prepare for the arrival of these disasters well in advance. So in a nutshell, these are the climate change impacts. The science of climate change is matured enough to say that our earth temperature is increasing, the sea level is rising, and changes in the hydrological cycle. Hydrological cycle in terms of, not only in terms of rainfall, but the entire the cycle of the water through our different spheres of the climate system is also changing, starting from the evaporation from the ocean surface that is increasing due to warming ocean surface, and then it translates to condensation, then cloud formation. These clouds are moving towards land, and then they are making intense and heavy and extreme rainfall. And when that rain is reaching the surface, most part of it is running away through the surface runoff, and then only a little part of it is being able to infiltrate and recharge the ground surface. That means water is circulating around all these spheres in a faster pace, so that water is not sitting at some place to make it available for the usable form. So that means these are the main issues linked to the visible or reality and the visible impact of climate change. How they impact the other sectors is through the changes in the weather pattern and water, both in terms of quality, quantity, and accessibility of the water, and then air in terms of pollution, and then toxic gases is being emitted to the atmosphere, and like surface, there are a lot of volatile compounds being emitted, like production of ozones at the surface is sometimes lead to many health issues, and then the ecosystem. So that we have not discussed much about the ecosystem part connected to the climate system, but the impact is realized mostly in the in a social perspective. It is mostly reflected in health sector by by a direct through a direct and indirect way. Direct way is by through the physical injuries caused by climate change, and then the health issues like transferring or the spread of vector-borne diseases are linked to rainfall and other temperature patterns. And then water quality is another issue which also directly linked to linked to the health issues. And then in terms of water and sanitation is another problem, because when a heavy rainfall event is occurring, the surface water is always most of times mixed up with the sewage water, so that it can create a lot of health issues. And then forest level changes, the ecosystem level changes is very much important, because if we are aware that a ecosystem is functioning with respect to climate parameters of a particular region, because the ecosystem is becoming a stable system with respect to the climate parameters, especially rainfall, temperature, humidity, wind. All these conditions makes a sustainable ecosystem. So that is declining with respect to changes in the temperature pattern. Sometimes the species they are migrating towards more comfortable zones, like tropical species are migrating to either towards polar region or towards higher latitude to cope up with the rising temperature, so that the ecosystem is disturbing. So the ecosystem from which one species is migrating to other ecosystem, it not only destroy the native ecosystem, also destroy the ecosystem to which they are migrating, because the new ecosystem, the new species will be considered as an invasive species, so that that ecosystem, that interdependence of the biotic and abiotic functioning also disturbed. So that leads to a lot of biodiversity loss associated with this ecosystem degradation, and that finally translate to agricultural, the crop failures or crop yield will be reducing. So that translate to food crisis or food security. So these are some of the impact of climate change. But in terms of the direct impact of climate change, especially in Kerala, that is realized through disasters, because all forms of the Kerala is becoming kind of multi-hazard weather hazard prone area in terms of heat waves, severe heat waves. They were most common, especially Rajasthan and other North Indian state, but that is propagating towards south, and sometimes forest fire is also frequently being observed. And then the heavy rainfall, flooding, lightning, landslides related to means triggered by heavy rains. And then in between the heavy rains, short spells of drought situation is also increasing, and also the tropical cyclone after the 2017 Oki event, tropical cyclones is also, and then the short type of tornadoes like mini gustinados are increasing. That is destroying most of the agricultural crops over certain area, so maybe localized region. And then the storm surges are increasing in with respect to this coastal erosion and tropical cyclones. These are the visible impact of climate change that is being realized in Kerala. So that translates to a lot of disasters in Kerala that we are experiencing. When we talk about the social stress connected to climate change, we have to think it in an integrated way, because the climate crisis along with the biodiversity loss is making the social stress. It is considered, the climate crisis can be considered as a stress multiplier, where the existing pattern of the social issues can be become more worse in the presence of extreme events. So the climate crisis, the biodiversity loss through some exposure pathways, like mostly geographical features or demographic pattern. So this through that exposure pathway, it affects the social stress through where the vulnerability is one factor and the adaptive capacity is another factor. Vulnerability more or less connected to the institutional mechanisms and the structural mechanism through which it is propagating to social stress, and also adaptive capacity nowadays due to climate change. The adaptive capacity of the society is also, it is more or less connected to the socio-economic pattern of the society. So that is also reducing due to this recurrent event of disasters. So when it comes to risk, if you look at the risk equation, if you consider, It's a combination of hazard, vulnerability, exposure, and capacity to cope. So the hazard is nothing but here we are discussing only about the climate-related hazards. There are two aspects of it. That one is frequency and another is intensity. The earlier climate, we can see that there were a lot of weather-related hazards were present in the earlier climate, but thing is that towards the new climate, the hazard intensity in terms of size of the hazard intensity and also the frequency of this hazard is increasing. So that means the risk is associated with this hazard is directly linked to the hazard pattern, and that is also increasing. So that's one way. Other pattern is more or less connected to other. It's a very complex. The vulnerability exposure, that is also some way or other connected to the climate factors. The recurrent climate events also makes the society more vulnerable, or more and more people are getting exposed to new pattern of this changing hazard. So that all this risk pattern, overall risk pattern is increasing. That is what here it is shown that the disaster risk is expanding with natural hazards due to climate change, and then exposure, the purely planned development activities. So the socio-economic factors, demographic factors, and the vulnerability, the poverty and environmental degradation, the ecosystem level changes also adds more vulnerability. That is also in a way these two factors also climate change makes these two factors more because the exposure condition is increasing, vulnerability associated with this is also increasing, not only with the hazard. So that this is a pattern we have to expect in future in terms of climate change. So coming to the Kerala situation, if you look at the last maybe 1 decade, 2015-16, where the worst drought condition we have experienced in Kerala. So that almost translated into agriculture and hydrological drought. That's that time in 2016, almost 35-40% deficit in rainfall, annual rainfall we have received. That was the extreme drought condition in that in a century period. So the heat waves are increasing, drought condition increasing after 2017, after the Oki event. This type of small tropical cyclones or depressions or low pressure systems are coming closer to Kerala and making a lot of issues, especially along the coastal belt, because Kerala has got a vast coastal belt of almost 600 kilometer stretch. So all this coastal belt is being affected due to this type of recurrent occurrence of these cyclones. And then floods and landslides are becoming a chronic issue here, because starting from 2018, before that also floods and landslides were there, but it becomes more problematic after 2018, 19, 20, 21, 22. Even we can see that 21, 22 monsoon season, the rainfall was very much deficit, but still we have experienced a lot of localized or urban flooding events and landslide events. This is the pattern in which Kerala is moving. So altogether we can say that Kerala is becoming a multi-hazard hotspot region, and there were compound weather events are happening. Already I discussed about this. These type of events are happening, and that induce most of the hilly regions like Western Ghats. The landslide is the main issue, and then coming to other midland and other coastal region, the flash flood, coastal flood, the fluvial floods are becoming more problematic. And then when all this, some of the times tropical cyclones along with the heavy rainfall, that together makes the compound events even more worse than ever, and the wave activities, coastal erosion, they are the pattern which adds to this, so that the Kerala is becoming a hotspot region for a lot of hazards in future. So if you look at the value of the disasters, the mostly we measure the value of the disasters in terms of either in terms of fatality, a number of death happened, and or in terms of the damage. So these are the but there are if you assess the impact of a disaster, we are normally forget about the impact it is going to make on a social system or in an ecosystem level. What were the impact? That is mostly we ignore that part, but the social system level impact and the ecosystem level degradation connected to the disaster event, that is not being properly assessed. Otherwise, the value of the disasters are being assessed in terms of number of death and damage, the economic damage, loss. So starting from Oki onwards, so almost like 400 people lost their life in the sea, the Kerala coast in the sea. That was the starting point of the bigger event. And then associated with a lot of almost like 1 billion loss happened in that. And then for post disaster event, even government has to spend a lot of money in recovering from this, and as a relief measure, government has to spend a lot of money in this. And then landslide in 2018, almost 700 people lost their life, and the US dollar 5.6 billion. It's a very huge amount if you consider US hurricanes, Katrina, Wilma, Rita, and also that is happening in terms of the economic damage is happening in at the order of billions of dollars. So that is also we have witnessed in 2018, and then flood 2019. Also, this is continuing. And another factor we have to consider here is the lightning. And lightning is considered as a very localized and random event. So the damage may not be that much spread over a large geographical region. So that is not being much discussed. But if you go to North Indian states like Bihar, Orissa and or West Bengal, the lightning kills because overall India we are getting almost like more than 1,000 people. It is claiming more than 1,000 people live in a year due to lightning activity alone. So that is also problematic in Kerala. Kerala also witnessing this lightning activity very often. And when we talk about the disasters in Kerala, the unique positioning, the geography of Kerala is the main important factor, because the Kerala is known by God's own country mainly because of the unique geography of our coast, our state, with respect to the Western Ghats region on the east and the vast ocean in the west, south, and east. So this is the uniqueness of Kerala, and this is the main thing which is making Kerala a unique Kerala's unique climate, and that is why we are known by God's own country. But that is changing, because coming to the Southeast Arabian Sea region, this is the region. This region is becoming more hotspot for severe cyclonic storms and very thick and intense thunderstorms, kind of mini cloudburst kind of event is happening over this region in recent times. If you look at the global distribution of the tropical cyclones, it is mostly forming over a ocean surface where sea surface temperature is more than 26 degrees Celsius. So our ocean is more or less having that threshold value, and we can expect naturally many tropical cyclones to form over this region. But if you look at the global distribution in terms of number, we are contributing only 5%. The distribution was like 1:4 between Arabian Sea and Bay of Bengal. If you consider the same latitude belt in the Western Pacific, Western Pacific is producing the largest number of tropical cyclones in a year, almost like more than 30 typhoons we can expect in the Western Pacific. Compared to that, it is very less, because this is mainly because we have two cyclonic season in the Arabian Sea, one in the pre-monsoon season and another. Then during monsoon season, there is no much cyclonic activity over Indian region. That is mainly because of we have the unique property of our region. The monsoon circulation and all is making this, and then the post-monsoon season also we have a very good cyclonic season. So that means even though the North Indian Ocean together is producing only 5 to 6% of total cyclone which is forming all over the world, but these are very, very much important. Even though with this small number, it's very much. That's mainly because of, if you look at, this is the sea surface temperature trend for 3 seasons. We can see that over the Arabian Sea and Indian Ocean, the sea surface temperature trend is always positive. as compared to Pacific and all. This region, we know that El Nino southern oscillation, and so cycle is there that is making it's a kind of natural discharge process, but it is not available over Indian Ocean region. If you look at the linear trend, we can say that Arabian Sea, the trend is like 1.2 degrees Celsius in last 117 years as compared to Pacific. It is less than 0.8. So that means that much over 0.4 degrees Celsius more warming is happening in Arabian Sea. That is the one reason for this all events. Like if you look at the distribution of the tropical cyclones between two epochs, this is the earlier epochs, 1982 to 2000. Bay of Bengal, we have a good number of cyclones happening. That is why our east coast was more prone to cyclonic activities. But the earlier epoch, though Arabian Sea is producing very little number, the distribution is not that much because near to Kerala coast there were no much cyclone is forming. But in the recent 2 decades, like from 2001 to 2020, what we observed is that the distribution is getting more wider in Arabian Sea. So that means near to our coast also, lot of cyclones are forming. And then, the Bay of Bengal distribution is almost remains same. There is not much change in the Bay of Bengal in terms of number of cyclones. So, but Arabian Sea, if you look at the increasing trend of cyclonic count, you can see that depression that is represented with the yellow color. So all this depression which is forming in the earlier period, that is getting converted into severe cyclonic storms. So that means that is mainly because of the warming Arabian Sea that is giving more energy to these cyclones, and this the earlier depression are getting more intensified in the presence of warming Arabian Sea. So that is the main reason for why warming Arabian Sea is producing more and more tropical cyclones. That is why our coastal belt is going to be more vulnerable to this type of cyclonic activity. And if you look at in terms of rainfall, this is the monsoon rainfall for 2013 to 17 based on the satellite data. So we have a good rain. We are getting good rain along this west coast, similar to this Myanmar coast. It's almost like order of like 300 to 350 centimeters of rain we are receiving along the west coast during a monsoon season. But if you look at the extreme rainfall contribution, the frequency of extreme rain event like greater than 10 millimeter per hour rain, it is almost like 24 centimeters in one day. So that type of rain is mostly happening over this central Indian belt. So all this region, there is a reason for that. If you look at the contribution of this type of extreme rain to this seasonal rain over a particular region, you will get this image. So that means the fractional contribution of extreme rainfall to seasonal rain over this region, especially the central Indian and west coast region, is mostly from extreme type of rainfall. Here we know that meteorologically there is metroposteric cyclone activity is there over this region. That is why here most of the rainfall, maybe more than 50% of this rainfall is contributed from this type of extreme rain event. But if you look at the Kerala region in the previous decades, there were no much contribution from the extreme rain, though we are getting seasonally very high rain, but it is not produced from extreme type of events. So then it is the story up to 2017. And if you look at the cloud top temperature is a kind of proxy of the structure of the clouds, because if cloud top temperature is below 200 or 210 Kelvin, meaning that type of clouds are very deep and very thick clouds. So that means this region, this green to blue region is present only over this area. So that means this area produce lot of heavy and deep clouds. Deep clouds meaning that the clouds can start from surface up to maybe 14 kilometers up to the atmosphere. So that means this much depth, the cloud depth is very much important, because the cloud depth is increasing means it can hold more water in it, and when it rains, that much water is coming to ground. So that is why this type of cloud is the main reason for this type of heavy rainfall over this particular area, and that is why the contribution of heavy rain is more over this region. Our region, Kerala region, mostly we are the rainfall, the cloud top temperature is greater than 220. So meaning that that type of clouds are very shallow. They may not extend maybe above 5 or 6 kilometers in height. So that is why we are not getting thunderstorms during monsoon season over Kerala region, but that is also changing. This is the story up to 2017. So this is the general picture of distribution of rainfall and how the cloud structure is contributing to this type of rainfall. So coming to Kerala region, this is the Kerala. The uniqueness of Kerala is that we are getting rain almost every month. Even January, this January also we got very good rain last week, and this week also southern parts of Kerala is going to get some rain from the low pressure system forming over Bay of Bengal. That means we are getting almost every month we are getting rain. So main rain season start from March to December, but here it is pre-monsoon season. The rain is mainly of thunderstorms type, and then monsoon season. Most of this 70% of our annual rain is produced from this month, June to September, and then we have another secondary rainy season known as post monsoon or the northeast monsoon. This is southwest monsoon and this is northeast monsoon. This is the unique distribution of rainfall over Kerala. That is the main reason for our biodiversity in terms of flora, fauna. That is why we are known by God's own country. This unique distribution you cannot find anywhere in world. So the spatial distribution is like we are getting more rain in the north annually, and this region south we are getting less rain comparatively, but in the monsoon season we are getting more rain in the north. But in the post monsoon season, like October, November, December, even January season, we are getting more rain in the south. This is how the seasonally the rainfall is distributed spatially and daily on a monthly scale, how it is distributed temporally. So this is how the basic features of the rainfall distribution, climatological normal rainfall distribution over Kerala. So coming to last 10 years, this is the departure of rainfall for the last 10 years, 1 decade. We can find that this is two things I have plotted here. One is June plus July deficit. That means 2 months rainfall departure. So meaning is that if the rainfall departure is above 20% or below minus 20%, they are considered as the extreme rainfall, considering the two accumulated rainfall for the 2 months. And the blue bars is the accumulated rainfall departure for the entire monsoon season. What we can observe from here is that our Kerala region, though we are discussing more on flooding event, but our general pattern is towards negative side, because we have mostly on the years with having negative rainfall departure, meaning that we received rainfall less than this is the monsoon season alone. So mostly in the last 1 decade, we observed deficit or the drought type of situation mostly. But only 2 years, like 2013 and 2018, we have excess years. So only 2 years contributed. Otherwise, there are 3 deficit years and 2 excess years. In the last 10 years, we have observed, like 2015 was a biggest drought year, and followed by 2016. So that 2 consecutive drought year produced a lot of issues in terms of water scarcity and water availability. So that means what we can say from here is that the variability of the rainfall is increasing a lot. So it is not just about the increase in extreme rain alone. The variability of the rainfall is increasing a lot. So another interesting factor here is that up to 2018, we can see that if June plus July rain is deficit below minus 20, then the full season will end up with a deficit. That blue and red bars will be on the same side up to maybe 2017. But in 2019 and 2020, what we observed is that though June plus July deficit was more than 25%, if we know that 2019 up to July, the deficit was almost like 35%. in June cumulative deficit was for June and July was 35%. But one spell of August made this 2 months worth deficit rain to the normal situation. So this is how the things are happening. The rainfall is becoming, seasonality of the rain is changing, and 2 months worth of rain is being compensated. The deficit rain is being compensated with 1 or 2 spells of rain. So if you look at the last maybe 3 years of extreme events, there are many ways by which we can identify an extreme. There is a general consumption that any rainfall which is happening, we consider as heavy rain or extreme rain, but all heavy rain spells may not be leading to extreme events. But there are many ways by which we can classify the extreme events. We devised some methodology to classify this. I am not discussing that, but otherwise 2018 we have a extreme event in the August, around 15th August. So the rainfall over the Kerala state was almost like 12 to 13 centimeters, but in the percentage departure is almost like 400% on the positive side. But in 2019, though we consider 2018 as the biggest flood event, but 2019 the rainfall was more. It's almost like 16.5 centimeters all over Kerala, and the percentage departure for that particular 6th August, not 6th, 8th August was almost like 600% more, considering the one particular day. So, and then in 2020 also we have a small extreme event. So this way we can identify extremes happening over this. Another factor is that we have to see that in 2019 1-day rainfall was more than even 2018 case. So that is the main attraction here. All extremes are not similar. So if you look at the spatial distribution, so this is the spatial distribution of the rainfall from IMD stations. These circles are IMD stations, and the radius of the circle is scaled according to the intensity, and in the red color represents almost like 1200 millimeters or 120 centimeters of rain. So the red color is also scaled according to the intensity, and the circle size is also scaled according to intensity. So we can see that in 2018, most of the Idukki region was getting almost like 120 centimeters of rain in just 5 days. This is 5-day rain accumulation during the previous period. So this is the period we have considered 5-day period, 5-day period, and 5-day period accumulation is considered here. And in 2019, we can see that there are not much heavy spells happened in southern Kerala, but in the northern Kerala there were a lot of. This is the time when Kavalapara Puttumala landslide event had occurred in 2019, and 2020 also the Pettimudi event in the Munnar Pettimudi event occurred in this time. So that means the 5-day accumulated rainfall over that particular region is almost like 120 centimeters. So 120 centimeters of rain is like a 2-month worth rain for a region, the average rain. So that means 2-month worth rain is being produced in just 5 days. So that type of rainfall is our native ecosystem, or the native Western Ghats, or the if it is occurring over the urban cities, our region is, our landscape is not able to accommodate this type of extreme rain events. So that means we have to live with this type of situation. So we have published 2 papers on this, because why the West Coast India's rainfall is becoming more convective. That means up to 2017, clouds were very shallow, but along with the changing nature of cyclonic activity over the West Coast region, especially Southeast Arabian Sea, the clouds are also becoming more taller and deeper. So that is also we observed. We analyzed the 2018 and 19 floods separately. There is a lot of difference in 2018 and 19 flood. So this is the paper, essence of the paper. So this trend of this deep convective clouds are increasing over the Southeast Arabian Sea of Kerala coast, and the trend in convective rainfall is also increasing. So that is the main reason. And there is another, thermodynamically, our atmosphere is also becoming, along with the surface heating of the Arabian Sea, the atmosphere is also becoming more conducive for producing deep clouds. Earlier time, this cloud will be extending up to maybe 5 kilometers. So they are shallow type of cloud. Due to this moist static energy difference, because there's a increase in moist static energy in the middle levels of the atmosphere is found. So that is the main reason for this type of clouds can able to penetrate like this. So this type of shallow cloud, in the presence of this deep layer of thermal instability, that can produce very deep clouds. So this is how the Southeast Arabian Sea is changing. This is also evident in Cape Verde convective. Available potential energy is also changing. So this is the main thing. If you look at this pattern, this is the cloud top. This is infrared brightness temperature derived from satellite. The meaning is that if brightness temperature is less than 200 Kelvin, they are considered as very deep and very deep and dense cloud. But the temperature, if it is above 215 Kelvin, that this region may be considered as a shallow clouds. So there are these the blue region represents deep clouds. The meaning, this is a kind of proxy, and the yellow to orange shades represent shallow clouds. If you look at 2018, this is animation of 2018, the cloud animation every 1 hour interval. So we can see that this type of 2018, there were no intrusion of deep clouds towards land. Almost like all clouds are general shallow clouds, and they are the color we can see that it is yellow to orange color shades. They are and even if there is small portion of this green or the blue color, it is not intruding to the land. But this is the case of 2018, though we consider 2018 was a century flood event. But in 2019, if you look at this pattern, so the clouds which is forming, the deep clouds, that is what we have shown there, Southeast Arabian Sea, this is the breeding ground of this type of deep clouds. They are intruding towards land. So that is the main reason, because this blue color is started intruding towards the Kerala region. So that is the main pattern we have to address this. So in 2021, the Kuttikal Kokayar event. So that also the cloud, the deep cloud which formed over this region, Southeast Arabian Sea, they are penetrating towards land and making the mini cloudburst type of event. So this is the snapshot from this. This is the satellite estimated rainfall. You can see that this is the Kuttikal Kokayar region where the landslide occurred in 2021 that claimed almost like 60 people's life, and there were a lot of damage, because as I told, there are a lot of economic damage associated with the degradation of the agricultural land of the farmers. So this region is produced almost like 24 to 28 centimeters of rain. And we know that because we visited this place, and we came to know that most of this rainfall happened in just in the morning hours, in between maybe 8 and 11:30. So that means almost all this 28 centimeters of rainfall is happening in just 2 or 3 hours. So this type of rain is considered as a kind of mini cloudburst event. It may not be similar to the cloudburst event happening in Uttarakhand or Himalayan regions, but this can be termed as a mini cloudburst, because this is also equally dangerous, because if traditionally cloudbursts are classified as 10 centimeters of rain in 1 hour. So, but if 10 or 15 centimeters of rain is produced in 2 hours, so the same damage, which is also having the same damage potential in terms of triggering the landslide, producing the flash flood, and the urban cities can produce urban flooding. So this is how the rainfall distribution is connected to the changes in the cloud structure is happening over Kerala region. And this is the Pyramid Kokayar region where very dense clouds are observed. So this region corresponds to the maximum rainfall we received. So that means this type of mini cloudbursts are becoming more common over Kerala region. So this is the location of landslide in that event. These are some of the location. This is the aspect I am not discussing. So we can say that this is a kind of by the way, we can predict the triggering of this event, because if you look at this rainfall, this is an index for factor of safety. based on the local conditions and rainfall, we can see that its factor of safety during the rain event is increasing. So this is the index. So if you look at the rainfall associated with this period, so we can see that the most of the rain, this is a total day distribution, most of the rain is distributed in just 2 to 3 hours. So that is how this factor of safety suddenly increase. Factor of safety is increasing means in a way it is negatively connected to the landslide susceptibility. So it is more means it has got more potential to make a triggering of the landslide. So this way we can link to the rainfall pattern, we can link to the probability of the occurrence of the landslide. And then the lightning activity, this is another one paper we have published. The lightning activity during this season also increasing over Kerala region. That is also another factor. And then coming to the cyclonic activity, because we know that 2021 we had a cyclone called Tokte, which actually the Tokte formed west of Lakshadweep, and it moved towards north along the west coast and then finally made landfall in the Gujarat region. But see, this cyclone, even if it is moving much away, because almost like 300-400 kilometers away from center of the cyclone, was away from our coast, but it produced, this is the picture from Waipin area, and this is from the Chellanam area. This produced a lot of water inundation in along our coast. So that means we don't have to get the cyclones to come or make landfall along our Kerala coast. Even without that, a cyclone which is moving away from our coast, maybe 300-400 kilometers away from the coast, that itself is producing this much damage to along our Kerala coast. And then just imagine if a cyclone is directly coming and hitting us, especially Chellanam, the urban city Cochin is close to Chellanam, so that will produce a lot of impact. So there's a lot of multiple cascading effect of this type of tropical cyclones. Though it is forming 200 kilometers away from the coast, it can produce a lot of heavy rainfall in the land and coastal flooding, because the heavy rainfall which is produced and all this water will be dumped towards the coastal region, and along with that, the storm surges produced or wave activity also creating water inundation towards the coastal region. All this together can make situation more worse. This is known as cross linkage of events and cascading of hazard. So what we need is that every month we have to come up with a climate proofing, like expected monthly rainfall and the percentage of the rainy days for each and every cities. And based on that, we have to devise our strategies. How many percentage of days we are expecting the rain, and then how many out of that, how many percentage of the time we experience this type of mini cloudburst event. That way we have to come up with the solution, and all our developmental activity is to be tuned in a way to accommodate this type of short spells of heavy rain. So coming to Cochin situation, the last 15th May 2022, this is the rainfall pattern for 5 days. One single day. This is the Cochin city. We can see that the Cochin city, we got almost like 20 centimeters of rain in just one day. So that is 20 centimeters of rain in May, or we cannot expect this type of this is a kind of rain which we are expecting during a monsoon season. Even before the beginning of the monsoon season, we are getting almost like 20 centimeters of rain, because 60 to 70 centimeters of the rain we are expecting for a month, especially during June, but out of that, half of that being produced in May. So this is 5 day accumulated. This is a constant spell, 5 day accumulated rain. It is of the order of 450 millimeters or 45 centimeters in 5 days. As I said, it is almost equivalent to a monsoon month worth rain. So that is also produced over our urban city Cochin. So that is also the main reason for this is similarly the Southeast Arabian Sea is producing this type of dense deep clouds. But this event we were lucky, because these clouds which formed off the coast of Kerala, this only some part of maybe 10 or 20% of this deep clouds were intruded towards the land. If just imagine like Kuttikal Kokkayar event, if these clouds were deep clouds were intruding towards the land, it would have been it would have produced more damage than than what we had. So in terms of there is a luck factor associated with this. Sometimes the clouds will move away from our coast without intruding the land. So this is a kind of luck, though it produced a lot of damage in the Cochin area. So this is how it is connected. And then coming to the temperature, we can see that the maximum temperature is also over Cochin or Ernakulam district is increasing, and minimum temperature is also increasing at a higher rate than the maximum temperature. So that means the city is holding more warmer state, because the minimum temperature is increasing more rapidly or more higher rate than the maximum temperature is, meaning that the average temperature is also increasing. So that is also another, that is mainly because of the we call it as urban heat island effect. So this heat related issue is also very much problematic for urban cities. Like if you look at the profile of temperature compared to a rural region and a urban city, if you coming from a rural region towards urban city, the temperature is increasing, the maximum temperature is increasing, and the minimum temperature as well is also increasing, and the difference between this maximum and minimum temperature is less compared to rural cities. So this is another factor. And another factor is that humidity. When we talk about it, the heat waves condition which is happening in the northern Indian states is different from the heat wave situation over Kerala region, because the humidity, the presence of high relative humidity is also contributing to this. The heat index, it is a kind of discomfort index, which is a combination of both ambient temperature and the humidity. The meaning is that suppose we have 38 degrees Celsius of temperature in the presence of 80% of humidity or 70% of the humidity, and the actual ambient temperature what we feel in is like 60 degrees Celsius. So this is how the ambient temperature is along with the humidity can make human more discomfortable. That is that is another situation, because as far as vulnerability is concerned, the marginalized poor and working people who are more exposed to this heat conditions, they are more vulnerable to this situation. And another factor is that because we are heading towards our summer season, maybe starting from March onwards, we are going to experience more this ultraviolet index, because the sun's vertical rays will be overhead, and it will produce more ultraviolet index will be above 10, that unit is 10, and it will be more between 12 noon and 2 noon. So along with this more ultraviolet index, that is the main reason for most of the sunburn issues which is found over Kerala region, especially during March to April time. So that is because of the direct exposure of the human to the sunlight. So this is how the rain connected to urban cities, how temperature is contributing, and then it is mostly this type of events will be mostly affected to the marginalized and the people the working class people, or the elder people, or the people having chronic health issues, or the younger kids. They are more exposed to this type of heating events. And now coming to the prediction pattern, because we know that after 2015, most of the northern states, they have implemented heat action plan, and also related to that heat related death, because as I told, the death related to lightning activity is almost more than 1,000 in a year. The heat wave related death was also of the order of same scale, more than 2,000 to 2,500. So some of them are not even reported. And if you consider after the implementation of this heat action plan, the better prediction of the arrival of this type of heat wave events, we considerably after 2016 we considerably reduced this type of health related issues, or the mortality related to heat wave events considerably. So that is how if you look at the disaster paradox, we can say that the number of disasters, the economic loss and the number of disasters are increasing, but if you look at the death rate, that is reducing. So there is some optimism in this. So this is mainly because of the better early warning system, which are capable of warning the arrival of this type of disasters well in advance. So here what I want to say is that the risk is a function of hazard, exposure, and vulnerability, but hazard we cannot stop. What we can do is that we can improve our ability to monitor and forecast this type of hazard event with more advanced early warning systems. So that is the main thing. So for addressing these issues, these exposure, vulnerability issues and capacity to cope, there are various level of actors who have to pay, because this mostly the institutional socio-economic factors are contributing, demographic, and even geography is also contributing. But otherwise, how we can live with this hazard is that we have to create better early warning system to predict this type of the arrival of this type of hazards well in advance. So this was our traditional approach. When a disaster occurs, we are running away from the disaster. But in the implementation of the early warning system, that will lead to early action. Then we can run away from the disaster even before it is arriving, and then we can invest our most of the time, effort, and energy in response activities and rebuilding kind of things. So here, what I want to say is that we have to have integrated people-centric multi-hazard early warning system in place, where the risk knowledge is one component and monitoring warning is another component. And then dissemination and communication is also very much important. Then response capability, that is very much linked to the institutional mechanism. So, but here the risk knowledge is important, because this is considered as the 3-4 legs of a early warning system. If any one leg is weak, means the entire the people-centric hazard warning system will collapse. So here what we want to say, we have the Kerala, we have good example of decentralized action plan in terms of health, education and all, but the disaster management and climate action also has to be implemented at the earliest, because here the people should be accessible with this type of knowledge and information. It is not just like a top to bottom approach, top down approach. It should be like bottom up approach, where the people should be provided with enough information regarding the arrival of the hazard well in advance, so that they are better prepared, and that has to be communicated without any kind of uncertainty or without any kind of it should be communicated in an understandable form, so that the uncertainty can be associated with this can be reduced. So this is an integrated approach we have to implement. So there are some examples of this. We are trying to develop this type of multi-hazard early warning system based on ensembles of models. And coming to that type of, this is a kind of technical part of it, I'm not discussing, because this was the kind of cyclogenesis probability we have given during Oki period, but it is not properly utilized. But before the arrival of Oki, the cyclogenesis probability we have issued like a 60 to 70%. This type of early warning system could able to save the lives. So this was the cyclogenesis probability during that time from this type of early warning system. So it should be utilized, because this was the 3-day advanced prediction of cyclogenesis from 28. This is the day the cyclone passed over our Kerala region. So this type of information should be properly implemented in a people-centric way, because people, especially the fishermen, should know well in advance this type of products, so that they can at least prepare for the event. Even during the flood event also, the 2018 flood, the 2-day advanced prediction was there. This was the prediction for the second week of August in 2018. We have predicted like a big event. This was a prediction for first week of August, and this is for the second week of August. You have predicted that first week of August there is a reduction in the rainfall. The second week we are predicting. This is predicted in maybe 1 or 2 weeks, 1 week in advance. So that means this type of prediction capability has to be integrated with the planning activities. And then this is an example of Kuttikal Kokkayar event. This was the prediction from system maybe 3 days in advance. The 3-day lead prediction was showing heavy rainfall even going to come over Kuttikal Kokkayar region, and that is being updated every day. The second day prediction is also showing kind of good rainfall over this region. So this has to be, what we need is that this type of information, which has to be integrated with floods and landslide and urban planning activities in a better way well in advance. We have to inform for the better informed decision making process. We have to integrate this type of information for not only for urban planning, the entire disaster management plan of local self-governing bodies. So that I will stop here. The early warning system is a chain of people linked to a chain of actions that makes it work. So I am maybe the old models are wrong, but some are useful. We have to utilize the available information in a better useful format. So here I will be talking. I am not discussing much about the resilience part because I have concentrated more on the hazard and how we can predict this hazard and utilize this type of information to at least inform the people well in advance and how to prepare for it. So I will stop here. Thank you. Thank you very much.
Thank you, Dr. Abhilash. It was excellent to listen to you, and you certainly brought a lot of issues which are not known to people who are not from meteorology, climate change, atmospheric science background, particularly the changing scenario, the thermodynamics effects, and how it's kind of complicating the life of a state which is rapidly urbanizing and nicely building the urban heat island effect and all those things, so how they are compounding each other and complicating the atmospheric scenario, resulting into many more unpredictable conditions and kind of leading to new risks which we were unprepared to address. So, and informing us about the change that has happened in the Arabian Sea, how it's heating up, and also the cascading effect from that. All those things were quite helpful. While you haven't really discussed and the resilient building part of it, but you have compelled all of us, I'm sure all in the audience will agree with me, you have compelled us to think how instruments such as urban planning need to be much more open, much more absorbing this knowledge which is coming from pure scientific fields such as meteorology and climate science, and how we can translate this knowledge through planning process, because it's ultimately, if you want to make a society resilient, society safe from these risks, we need to know the periodicity of the risk, the type of risk, the kind of what is contributing to the frequency of such risks in a society. So all those things that you have very nicely explained has been very helpful. And there had been cases, we haven't tried such things in India for sure, but I am aware of certain research which UCL has done a few years back about thermodynamics of cities. So how city environment, and so while you were presenting the complicated situation in Kochi, I was just trying to understand whether is there any further relationship between Kochi and its immediate ocean environment? Is anything that is happening independently in the ocean and atmosphere? Whether anything is further complicated by what's happening in this heat exchange between the city of Cochin and so some questions in my mind, probably they are not really well formed, but I started thinking what is the way we will be able to kind of build our state much more resilient. Can we have new materiality? Can we relook at the way we urbanize? Can we, of course, urban planning now Kerala has piloted the risk-informed master plan, where the dynamic risk need to be part of the planning process, and also the multiple type of risks, not just about floods or landslide, but also other forms of heat stress. So, any society which is high entropy is certainly going to become much more unsustainable. So you helped us to kind of see through, relate, link all those disconnected, disjointed parts, and it was quite helpful. I have personally gained a lot. So thank you for that. Now, I think it's important that you also get some feedback from most of the audience, and I'm sure there will be questions also. Kapoor Saab himself might have some question, and I'm sure Professor Jayakumar and Sundararajan, they all will have some questions.
I'm Sundararajan. I just have one question to Dr. Abhilash. First, let me congratulate you. It's very, very nice work. A lot of learning, a lot of interesting things. But I think one critical aspect you have missed in all your study, that is the Western Ghats biogeographic zone. All these factors, because there is almost 70 to 80% changes graphically, if you say, from years to come, and even in our own ground surroundings, if you see, all are very young trees. All the older trees which were very big all disappeared. So what I am saying is the entire geographically, if you see, there is a 70 to 80% of geographic, and Kerala you cannot see in isolation. It has to be seen as a biogeographic. So Western Ghats, it is about 350,000 square kilometers. Kerala is 38,000 square kilometers, and Kerala is behind Kerala, Tamil Nadu area is also there. When you look at it, it's a huge area, and you are talking about the simulation and all. You can see the clouds are moving towards these Western geographic zone and going back. So this is very, very important factor which you are missing in all your studies. This is my humble comments. I have several other questions which maybe I will be interacting with you, but kindly clarify this one. Thank you.
Thank you, sir. Thank you, sir, for the nice words. Actually, on one side, climate is changing, and on the other side, Western Ghats is degrading. That is two factors. Even the native Western Ghats, without any much anthropogenic interventions, cannot able to sustain or withstand this type of increasing rainfall pattern. Even if you consider, because there are a lot of, even 2022, most of the landslide has occurred in inside the forest. So that is sometimes it is not even being reported, because it will be realized as a sudden burst of water level rising in a stream or something, but it may not be noticed. So this is happening because the Western Ghats, if you look at the age of the Western Ghats, it is more than millions of years, 200, 400 millions of years. So that means already there are a lot of weathering has happened in Western Ghats ecosystem due to climate events and other natural process. So already Western Ghats is stressed. And along with that, the anthropogenic factors is also contributing. And the main thing is the triggering factor is the climate. Most of this event is triggered by extreme rainfall events. As you said, Kerala should be considered as a single unit, not like hilly area or the midland or the coastal region. When we plan something, we have to consider Kerala as a whole, because Kerala is overall Kerala can be considered as a expanding big urban state as a single unit. So that also should be maybe future. We cannot separate urban cities from it, because urban cities are also expanding considering our densely populated area and our limitations in the land. All these factors we have to consider. Yeah.
Okay. Especially one particular aspect you told about the change in the number of events happening in the Arabian Ocean, and the change of the number of it was happening for several centuries in the western Bay of Bengal. So there is an increase in here. So if I see a correlation between what the degradation happening in the entire biogeographic zone I'm talking about from Mumbai to south to Kanyakumari, that's the entire area which I'm talking about. So it has got a relationship. When you see the simulations, and I was looking at the movement of the clouds or whatever you are showing, it's everything is happening only in the western this area, and it's going back and moving it. So its influence was very high, and it was not factored into your studies. This is what I wanted to say.
Yes, that is a good comment. Sir. Yeah, thank you.
Yeah, thank you. That's the only one I want to make now. Yeah. I will give to others now chance.
Hello, sir.
Thank you.
Hello, sir.
Yeah, we can hear. Please go ahead.
Sir, we have to congratulate. This is very informative and very good, sir. But this is continuously occurring, the flood in Kerala. We have to think, according to me, we have to think about interconnecting the river basins from the upper levels itself. For example, this Palakkad is a very drought region. Why we can interconnect to this excess water from Parambikulam, lower Sholayar, upper Sholayar, and finally it will come to the Peringalkuttu Dam. From there, there is a natural valley. If we can, with using that one, making another tunnels, all this water we can store to this Mangalam Dam, something like that, sir. And even from the upper levels, this Mingara, Chulliyar and Punakadavu, these basins also we can use. So while the flood, more rains and the flooding is happening, we have to think interconnecting the these river basins to another river basin where the rains are not there. So that also we have to think, sir. According to me, sir.
Yeah, it's a very excellent and good suggestion. For that, we have to integrate this type of dynamic evolving pattern, because we should know in which basin the rain is going to be high, so that the expected basin where rain is less, we can divert that flood water to that basin. Like, it's a very, very good, nice suggestion.
We can say this Chalakudi River Basin, the water transferred to Bharatapuzha River Basin hundreds of years before. Already the water is flowing before the water is going to Tamil Nadu, and this Bharatapuzha having very sufficient width. Such a way, this problem in Cochin, simultaneously the water from Mullaperiyar, from Idukki, and the same way the Chalakudi Basin, also the Parambikulam, Upper Sholayar, the so many dams are there. Everything is opening together. If we cannot control in the final stage, we cannot, due to the heavy rain, even the dam capacity is over. We are opening everything together. Then the extreme, the lower region is fully flooded, sir. So such mechanism, constructive mechanism for diverting also we have to think, sir.
Yes, sir. Yeah, especially for Chalakudi Basin, it is a very complicated basin because it is a interstate connected water. So we don't know from Tamil Nadu, Sholayar, Tamil Nadu, when water is being released. So that it's a kind of very complicated river basin where more than rainfall, the dams are contributing much on it. Yeah.
This is our opinion for, as representing Ransford, sir.
Yes. The last time also it was happened like all together, most of the dams were open. But luckily in the downstream, the next day there were no rain. That saved Chalakudi Basin this year.
It's a major issue.
Yeah. Good suggestion, sir. Maybe the policy makers can think about that.
There are still about 39 people, so you may have more questions. Kapoor Saab, will you have some questions to Dr. Abhijit?
No, it was wonderful to hear the good presentation, but I'm worried that you talked about the actions for reducing the damage, whether it's a physical or human life. But ultimately, we have to think about that, how to restrict the issues of climate change. We talk about that by 2030 or 2050, we will be net zero carbon emission, which may or may not be possible. But definitely the political will is there among different countries that cannot be done by one nation itself. All of us have to work together to make it happen. So what are your take on this? That because always we say that prevention is better than cure. We can definitely reduce the damage, but how to prevent the hazards or disaster happening?
a very complicated question, sir. And whatever we have I tried is here is adaptation part to how to better adapt to the current situation, not like by 20 the projection based on the projections. They are just projections only. We also don't know what is going to happen maybe after 2030 or 2050. So the global commitment is 2050, the net zero emission by 2050. For that is considered as a mitigation effort. But considering the faith of Kyoto Protocol and the Paris Agreement and all, and I am not that much confident to say that it is going to happen, because all linked to developmental activities and many other factors. So the ultimate aim is to mitigate means the damage from the global warming, from the source itself. But it involves a lot of means global action, not like a Kerala state, because in terms of energy, because if you consider the carbon dioxide emission from a different sector, the 73% right now is contributed from energy sector. That is basically and 80% of that is produced from fossil fuel. So India's commitment is towards, even though net zero by 2070 and 2030, we are planning for 500 gigawatt from renewable sources. So the energy sector is moving fast. So that is the one way by which we can transform the fossil-based energy sector towards renewable energy. Still, how we will compensate the coal-based energy sources, still that is also another challenge we have. Yeah.
Wonderful presentation.
Thank you. So are there any further questions?
Can I just have one last, sir?
Please, Akhil, go ahead.
Hello, sir. It was a wonderful presentation, sir. I had one just doubt. Recently, we are hearing of Joshimath in Uttarakhand area, where this land subsidence happened. But it was not happened within 1 or 2 days. It was happening for past few years, maybe 4 or 5 years, it is happening. But when it reached its saturation level, means around 70 or 80% of the constructed there were damaged, then only people or the news agency, everybody came forward and saying that this has happened. So this type of things or this type of locations are there in Kerala itself. I am not saying that it will be directly affecting here, but that type of activities may happen here also. So for that, it cannot reach the maximum point, because it is already 70 or 80% damage has been done. Then only people are realizing that this has happened. So that mitigation process which has happened for past 4 and 5 years, that part can be adopted in Kerala model itself. I am saying that you can also suggest based on that one a year-wise approval, means what can be done or mitigated, how it can be mitigated, like that one approach can be used in your final studies. This is just my suggestions. It is up to you to decide. But this is my just humble suggestion on this topic, sir.
Akhil, I am interrupting in between.
Yes, sir.
He has very rightly said that the early warning system should be people-centric. What had happened in Uttarakhand, people knew that something is happening for so many years, and they did not realize that it will go to that extent. The damage was not foreseen as it happened today. So, because there was no people-centric approach for warning them that it can lead to what. So they kept on constructing. The government also kept on making projects. Lots of projects have come up, large projects. So ultimately, they continued the damaging the nature without realizing that to what extent they have to suffer. So he has very rightly pointed out that early warning system should be people-centric. Everyone should have realized that what damage we are putting a one stone or one floor on my house, I am inviting that disaster for myself. People did not realize because nobody was there to teach them. Am I right, sir?
No, sir. This is very informative, giving Kerala people the self alert where we have. In previous years, we are thinking we are the safest land in the world. But now the scenario changed. Continuously, due to the global warming from Arabian Sea, most of this one from Bengal Sea and less, now increasing from Arabian Sea, we cannot control. We have to plan according to the conditions, sir.
Yes.
Okay.
Responding to Akhil's comments,
Go ahead.
Yeah, you have rightly pointed out. So each area we should come up with a threshold of development and the threshold carrying capacity of each area we have to come up with, whether it is coastal area or urban area and or hilly area. Each area we have to come up with what type of development, what type of capacity it can hold. So that type of threshold, based on that threshold only we have to build on that. So that may be the situation may be different for Kerala. It is Joshimath is entirely different terrain because Himalayan tectonic zone is there and tectonic activity is happening. So that is contributing a lot in this. And along with that, geographically it is a vulnerable area. And along with that, a lot of construction activity is happening. So if the same construction is happening over another place, it may not produce this much damage. So that means we have to identify the area in which what type of development we can do and the carrying capacity of each area in terms of what type of development we can do in a sustainable way.
Okay, sir. Thank you, sir.
Great. Abhilash, do you want to take more questions? I think.
No, sir, we can.
Okay. Anyone from ITPI Kerala chapter? Anyone other than Akhil who wants to ask? Jayakumar, sir. Rajesh, anyone else?
Oh, nothing more to add. It was a very good presentation. Thanks to Abhilash and Pradeep Kapoor and all the members who have joined the session.
Great. So, Abhilash, just to before we close, just wanted to make a couple of points. I'm sure you know this. So, because there is greater exchange of ideas and knowledge between all these key players now, what you are doing, KSDMA, and what we have been doing at KILA to engage and equip the local governments, the elected councillors, and the entire new framework that LSGD planning has put together for risk-informed master plans. I think this is going to some way help us to safeguard our urbanizing Kerala. But what will be most important is how frequently we will be able to access this dynamic information, which is only available with probably you or some of those agencies which has got specialized instrumentation and talent to manage that. How do we democratize that knowledge? How do we prepare and the entire society? So communicating, you actually have had it in your slide, risk communication, which is a significant part we will have to invest in, and we will also have to consciously build this into the knowledge, thinking, and institutional frameworks of most of the institutions. Because as one of the participants mentioned, we have moved from a very safe community and society to one which is very vulnerable, and there are multiple risks, and risks are communicating with each other, as you showed, they are compounding the entire effect and vulnerability. So do we need this kind of a, urbanizing this pattern where 10 lakh houses are lying vacant and then you are keeping on building, you are digging all the hills, you are building over across all the river plains, you are not moving into a community living. I keep saying this. When the flood happened, when the COVID happened, people got narrowed into small pockets. They all got into schools, community places and premises. but otherwise they are expanding throughout the state. They are going to the hills. They are doing. So I think even the housing typology, housing pattern, and also our, we need to probably relook at how Kerala need to urbanize, much more compact, less sprawl, much more. And also energy is a big challenge, because my gut feeling is that there is correspondence between what is happening in the land from Kochi or other regions with the sea also. So this might also be adding to our trouble. And we are already vulnerable because heat is increasing on one side. And we are adding to that by becoming much more, friendly to air conditioning equipments. Our own personal and individual capability to absorb some excess heat is reducing. There are epidemics queuing up because of the other challenges around us. So I think all those kind of things are going to make us much more vulnerable. We need much more organized, much more compact, and societies and communities where people are able to care and support each other much easily and as much away as possible. So I'm sure you are aware of this shift Indonesia is doing. The Jakarta, the capital, is moving from to Borneo forest. And similarly in Addis Ababa also moved to Dodoma, so more inland. And if you look at Kochi's natural migration, it is moving towards Thrissur. It's slowly moving inward. So sometimes it's important to decommission all these institutions which are quite close to the coast and then look at possible alternate avenues. So I think we collectively need to bring this into spatial intelligence, which is what Rajesh and other colleagues at LSCD Planning is trying to do. So I think working together, refining our shared knowledge, and then bringing into policies, and also parallelly, as Pradeep Kapoor sir mentioned, equipping people through training and democratizing this whole knowledge. I think we will be able to possibly safeguard ourselves and show some model to other parts of the country as well. So thank you once again. I would like to thank and congratulate Dr. Abhilash for this wonderful presentation. Every time I heard him, I found something new, and I got enriched from the knowledge and the set of information he shared with all of us. And for ITPI Kerala chapter, the president, Sri Rajesh PN, the entire team, Raji, Akhil, and all of them, it was great that you organized this event, and it was quite beneficial for all of us who attended. Kapoor Saab for sitting throughout the 1.5 hours and also compelling us to think beyond what we have been thinking. So thank you everyone. I think I just did this as part of my part of moderation, but there is a formal thanking and closing by Akhil. So over to Akhil. Thank you.
Thank you, sir. I will directly go to my task assigned, that is giving vote of thanks. First of all, we are honored by the presence of Sri Pradeep Kapoor, sir. In his busy schedule, he has agreed to be our main introductory remarks. So to give our introductory, he has agreed. For that thing, he has also elaborated on what are the basic things which we have to cover, how the cities has to be evolved, how planning has to function based on the disasters which are occurring not only in Kerala but apart from that in all India. So once again, thank you, sir, to be a patient listener for and also a participant in the event. Thank you, sir. Thank you very much.
Pleasure.
Next is Ajit Kaliat, sir, to be our main moderator. He has organized this in a very good manner. Not only he has spoken about his experience, because he is the apt person for this type of thing, because he has international experience, exposures also regarding disasters and related to planning matters also. So he has conducted and organized this deliberation in a very good manner. So sir has given us points of thinking like urbanization pattern, housing pattern, how energy and health benefits can be attributed to disasters, how we can mitigate as a planner, how we are think of these activities in a different manner, not only just based on the economics, but based on other aspect also we have to think. So he has kickstarted this deliberation, giving us ideas how we have to do for this deliberation parts. So thank you, sir, for being a very good moderator. Thank you once again, sir. And last of all, thank you, Abhilash sir. It was such a wonderful presentation. It is, if you say disasters in Kerala, these have different subtopics. Each topic will have 1 or 2 hours deliberation, but you are able to mingle this entire thing and give us a deliberation within the 1 or 1.5 hours. You are able to tell us what are the type of disasters which are happening. And if we can just brief your presentation, you have said what are the type of disasters and why we need this mitigation process to deal with this, how it is impacting the society, and how these disasters can be mitigated in a very short manner. So the damage and fatality and its economic liability can also be done. And the procedures of this you had explained in very good manner, sir. Apart from that, it was very interactive also, because you have shown so lot of maps, interactive ideas, data. So we were never being felt as a bored person. So thank you, sir, for such a wonderful presentation. Thank you, sir.
Thank you.
And last of all, I thank all the participants who have attended the web talk event and make it an interactive session. Thank you all. Thank you, sir.